Welcome to another of my videos where I work through and explain A-level Physics multi-choice questions. If you want to try to answer this question yourself, pause the video now. If you got the answer B, well done. If you'd like to hear my explanation of how I found the answer, please continue watching. So we've got a primary winding on a transformer of 200 turns and a secondary winding of 1600 turns. A root mean square alternating voltage 25 volts is applied to the primary side, causing a primary RMS current of 4 amps. The transformer is 90% efficient. And we need to find the RMS values for the secondary voltage and for the secondary current. So to find the voltage, I'm going to use the equation that the number of turns on the secondary over the number of turns on the primary is equal to the potential difference on the secondary over the potential difference on the primary. So that gives us the voltage on the secondary is equal to number of turns on the secondary, number of turns on the primary, multiplied by voltage on the primary. Let's put some numbers in there. Number of turns on the secondary was 1,600. Number of turns on the primary was 200. The potential difference of the primary was 25. That gives us a potential difference of 200 volts. 200 volts, either answer A or B. Now we need to find the current. Well, to find the current, we're going to find the initial power. Power in equals power out less the power lost in the efficiency due to the inefficiency of the transformer. So I'm going to use the equation power equals potential difference times current. So on the primary side, the potential difference was 25 volts and the current was 4 amps. So the power was 100 watts. Well, we're told the transformer is 90% efficient, so the power out is going to be 90 watts, 90% of 100. I'm going to rearrange this equation for the current. Current is equal to power over potential difference. My power on the secondary side is 90 watts. My potential difference on the secondary side is 200 volts. That gives me a current of 0.45 amps. The answer is B. If you found the video useful, please watch more of them, please subscribe, please share, and watch more of them in the series. Thank you very much.